So, hello friends, I'm back again with another session for your fundamental chemistry, and this time it's with your organic compounds. The IUPAC nomenclature is something very important when we start the organic compounds studies. And I hope in this pandemic everybody is staying safe. And as I always say, be positive, but then test negative. So with this, we start today's session. Let me share the screen and we start. Now, organic compounds, they are also known as hydrocarbons because the parent chain is made up of carbon and hydrogen atoms. So they are also known as hydrocarbons. Now, these organic compounds consist of two sets. One is your aliphatic hydrocarbons, and the other set is your aromatic hydrocarbons. Now, when we talk about aromatic hydrocarbons, then they are basically derived from the word aroma, aromatic. Why? Because aroma means smell, and these aromatic hydrocarbons are having a very particular and a very strong smell. So they are also known as aromatic hydrocarbons. But science is based on facts. So the factual definition says which contains at least one benzene ring. Now, what is this benzene ring? The formula for the benzene ring is, the molecular formula is C6H6. Kekulé was the scientist who gave the structural formula for the benzene. This is the structural formula, which is somewhat like this. The inner ring represents the three alternate double bonds which are present in your benzene ring. Now, we come to the first major part of organic compounds, that is the aliphatic series, which is very important. Alkanes, alkenes, alkynes. Now, the formula for alkanes is CnH2n plus 2. The general formula for alkenes is CnH2n. And for alkynes, it is CnH2n minus 2. Now, in all the three formula, your Cn is common. The value of N in case of alkanes is either equal to 1 or more than 1. For alkenes, it is either equal to 2 or more than 2. And for alkynes, it is either equal to 2 or more than 2. Why? Because in alkanes, there is a single covalent bond throughout the series. But in alkenes and alkynes, there is a multiple bond. Multiple bond means that there should be at least one double bond present in alkenes. And in alkynes, there should be at least one triple bond present in the series. Now, hydrogen atom is monovalent. It cannot form the multiple bonds. Therefore, the series starts from 2 in the case of alkenes and alkynes. Because of the single covalent bond throughout the series, your alkanes are considered to be saturated hydrocarbons, whereas your alkenes are considered to be unsaturated, and so your alkynes, because of the presence of the multiple bonds. Now, we come to the naming part, that how we will name. That is something very important. When we have to name, the value of N is equal to 1. That means there will be one carbon atom. The name will always start from meth. If N is equal to 2, the name will start from eth. If N is equal to 3, the name will start from prop. If N is equal to 4, the name will start from but. And if N is equal to 5, then the name will start from pent. Now let's see the series. If I talk about alkanes, the formula is CnH2n plus 2. Now there are two kinds of formulas for organic. One is your molecular formula and the other is your structural formula. Now let's see how we write both the formulas. If N is equal to 1, then the first member of alkanes will be CH4. This is the molecular formula because we are writing in terms of atoms. In the structural formula, we will show the bonding. Now we know that carbon atomic number is 6 it requires 4 electrons to complete the stable configuration. Hence, carbon is considered to be tetravalent in nature. So this is the structural formula where you are showing all the bonds. N is equal to 1 will not exist for alkenes and alkynes. As I have already mentioned, the series starts from N is equal to 2. Now, before we start the series, the naming part, if N is equal to 1, your name will start from meth. So, here we will write METH, meth. Because it is alkane, we will add ANE. So, it becomes methane. For alkenes, when we are talking, the formula is CnH2n. Okay, there will be no further minus sign. This will be something wrong. The exact formula will be CnH2n, as I have already told. So, N is equal to 2. Formula becomes C2H4 because there should be a double bond. So, we are placing the double bond between the 2 carbon atoms. And here goes the structural formula. Because N is equal to 2, so the name will start from eth. We will add ENE and it becomes ethene. Similarly, for alkynes, the formula will be CnH2n minus 2. So you will be writing the formula as C2H2. This is the molecular formula. The structural formula will have 3 triple bonds between the 2 carbon atom, which is the condition for an alkyne. And this is the series? No. If I draw this as the formula, then you will find that this formula is wrong because we are not placing the hydrogen atoms as per the molecular formula. So the correct formula will be already 3 bonds are present between the 2 carbon atoms. So it requires only 1 bond with hydrogen to complete its octet state. Similarly, for the second carbon atom, this will be the structural formula for ethyne. Why ethyne? Because N is equal to 2. So the name will start from eth and we will add YNE to make it ethyne. So this is the series for alkanes, alkenes and alkynes. How to write the names. Now, there are plenty of organic compounds which are existing. But when we draw the structural formula for alkanes, alkenes and alkynes, we find that there is no space for the other group atoms to come and combine. So there is another series which exists, which is known as alkyl group series, where the formula is CnH2n plus 1. This is homologous to alkanes because for alkanes the formula is CnH2n plus 2. 1 hydrogen is less in alkyl group, which imparts the space for the functional group to come and get attached. So when N is equal to 1, the series is CH3 and we will make a hyphen to show that 1 vacant orbital is there in the carbon atom. If N is equal to 2, it will be C2H5. If N is equal to 3, it will be C3H7. If N is equal to 4, it will be C4H9. And if N is equal to 5, it will be C5H11. The name will be methyl, ethyl, propyl, butyl, pentyl. So, as per the number of hydrogen atoms present, we are writing the names. This is something basic part for your nomenclature for the organic compounds. In the next session, I will be coming up with the nomenclature of the different functional groups. So, till then, stay safe and stay connected. Thank you.